So actually, so this is the mass to charge ratio, but actually this charge, as you can see in all of these cases, is plus one. We have a plus one charge over here, we have a plus one charge over here, we have a plus one charge over here, a plus one charge over here, a plus one charge over here. But so actually we take this charge as plus one always. So molecular mass divided by plus one, which will be the molecular mass, the relative molecular mass, or MR as we call it. So actually the mass to charge ratio is nothing but the relative molecular mass of the fragments. So the mass to charge ratio for this will be the molecular mass of the CH3 plus group, the CH3 group, because we can ignore the plus over here. The mass to charge ratio for this will be the CH3 will be the relative molecular mass of the CH3 group, which is basically the molecular ion, and the relative molecular mass for this will be the mass to charge ratio for this will be the relative molecular mass of CH3CH2. So it goes on like this. You take this charge as 1, and basically what you get is the molecule, the mass to charge ratio is simply the relative molecular mass of the fragments. Yeah, so this is it about fragmentation. And yeah, a very important point, the tallest peak in the spectrum is the peak representing the most stable fragment. So whenever we get a long, we will be looking at what a mass spectrum looks like. So whenever we get a really long line in the spectrum, for example, we have a spectrum like this. So actually on the y-axis we have the relative abundance, which is the percentage abundance on the y-axis. So it's relative abundance. And on the x, and this is given in percentage. This is the relative abundance on the y-axis, and on the x-axis we have the mz ratio. So this is what I said, mass to charge. M is the mass, the molecular mass, Z is the charge. This is the mz ratio, and it is nothing but the molecular mass of the fragments. So so the tallest peak on the MR spectrum, on the mass spectrum, the tallest peak on the mass spectrum basically represents the most stable fragment, and this makes a lot of sense, because the most stable fragment will be present in the most will be most abundant in the sample. The most stable fragment will be most abundant in the sample, and that's why its relative abundance will be the highest. So you must remember this thing, that it will have the highest relative abundance, the most stable fragment, and the y-axis is the relative abundance in percentage. The x-axis is the mass to charge ratio, which is nothing but the molecular mass of the fragments, because the charge is 1, and whenever you divide something by 1, you get the quantity itself. Like in this case, the quantity we are dividing by 1 is the molecular mass, and when we divide it by 1, that's what we get. So yeah, it will be the MR basically, but we call it the mass to charge ratio, and this is it. So let's move forward. The molecular ion peak. So let me again make the mass, a particular typical mass spectrum. This is my relative abundance. In percentage. This is my